Yes, sir.
Fine. So this is the topic we discussed in the previous class. So that's mean if we release a block in an inclined plane with the two different mass, so and I ask you which block is going to be the move to the downward first, and the answer was is both the block will be reach at the same moment at the bottom, right? Since it's a frictionless, we consider that case. If it is frictional, then the situation is going to be different. We'll discuss this thing today. Fine. So before that, we'll also use the idea, say that case. I'm going to talk about a case right now over here. Say we have a inclined plane, a ball in the inclined plane. If I want to keep stationary, so this is a inclined plane, and I want to keep the solid ball over here with say some string. That is string is connected over here, and somehow say it makes a stationary over there, and this angle of this inclined plane is 35 degree, and we say that the mass of this solid ball, which is 5 kg, and the tension in this string is T. Now the question they asked two questions. Calculate that tension in the string, which is the first question. Second question is, it is basically say that how hard does the surface of the ramp push on the ball. So how hard does the surface of the ramp push on the ball? So that's mean how much force will the surface will apply on the block, which is basically the normal reaction force over here. We have to find out that one. For that one, I have to draw the free body diagram. Try to understand this thing. This is very important concept over here, the free body diagram. So this is would be your mg, right? This is the and this I can say this is would be my reaction force, normal reaction force. Remember, it should be perpendicular to that inclined plane, because right now we are dealing with this inclined plane. Then I can say, since this angle is 90 degree, this angle is theta, or mean 35, then this is going to be 90 degree minus theta, right? Now you split, if you split these two vector, say that this m I have to split in these two direction, right? So this would be the case. This is would be, since this is 90 degree minus theta, then this would be mg sorry, I am writing at a time, because cos of 90 degree minus theta is going to be sine theta. So I'll write mg sine 35, this component. This component will be mg cos 35, right? Fine. Now let's think about for t. Say I choose, so this is my reference axis, this is my positive x direction in the direction of the inclined plane, and this is my positive y direction. Then if I split that t also, I have to split in that direction. So one component will be this one, and another component will be that one. So that's why this is will be a resultant tension in the string. Now what will be that component? What will be that angle? If I can find out that angle, I can find out this one. This angle is 90 degree, right? What will be that angle over here? Can anyone tell me what would be that angle? This one. Can anyone tell me what would be that angle? It should be 35. Come on guys, try to understand. It will be 35.
Sir, will it be 35 degrees?
Yes, it's a 35 degree, definitely. So that's why it should be t cos of 35. Then I can say this one will be t sine 35 degree. Right?
Yes.
So fine, to since the total system is stationary, is not moving at all, then I can write For first one, since I'm going to find out the T from there, I'll write down the net force along to the x-axis must be equal to 0 over here because it's not moving at all. Then I'll write T cos 35 degree, which is towards the positive x direction according to this reference axis, minus mg sine 35 degree, right? Sine 35 degree must be equal to the 0. Then I can find out the T from there directly, because in that case T would be mg sine 35 divided by cos 35. That's going to give me tan 35. I know that mass, which is 5 into 9.8 into tan 35. If you plug in that value, you will find out the value of this tension would be 34 point something. T would be 34.3 Newton. So this is would be that number 4. Sorry, tension in the string. So this is the answer, question number 1. In the second question, I have to find out the normal force. I will apply again the Newton second law in the y direction. What would be that? If I apply net force along to the y-axis is 0, because since it's not moving at all, right? That's why along to the x direction the resultant force would be, sorry, y direction would be also 0 over here. Along to the y direction, I have 3 forces. N is the towards the positive y direction, T sine 35 is the downward direction, and mg sine 35 is also towards the downward direction. So that's why I'll write it would be N minus N minus mg cos 35 minus T sine 35 equal to the 0, right? Then I can find out that N, which would be mg cos 35 plus T sine 35. I know that value of everything of this parameter in this equation. I know the mg, I know the T. Then if I plug in, then I will find out this normal force would be 59.78 Newton, which is definitely the apparent weight of this block or that solid ball, because its normal weight would be mg is basically more than that, so that's why it would be apparent weight. It is different from that, so that's why it is apparent weight. Now say I have a block in a horizontal surface, this one, and I'm going to drag this block by applying some force which is 15 Newton, and it makes an angle with that horizontal is theta. This is the angle is theta, and this is the mass. Mass is given. Mass m is basically that 3 kg. Due to that force, that system moves towards that rightward direction at a acceleration a. We have to find out that acceleration. The question they ask, calculate a. What is a over here? Second question, calculate the normal force onto the block. And number 3 is, what is that? Because when you apply this force 15 Newton, there is a probability if you increase that force, the block could be fly off that surface, right? It could be if you apply some force, definitely at a certain point that the block will be fly off that surface. We want to find out what would be that minimum force we could apply for this block so that it could be fly off from that. So if you apply that amount of force, it will try to just fly off. If it is more than that, definitely it will be away from that surface. We want to find out that minimum force over here also. Fine, let's draw the free body diagram. We can draw, this is should be your mg, since still we are considering the frictionless surface. This is should be your normal force, this is should be your 15 cos theta. Theta is given. Theta is basically the 38 degree. I'm sorry, theta is 38 degree, and this is 15 sine theta. Right? This is the case. So if you want to find out that acceleration, in this case I'll write net force along to the x direction equal to ma. The only force along to the x direction is the 15 cosine theta. From there I can find out the a would be f cos theta divided by m. So f cos theta is basically over here 15 cos theta. Theta is 38 degree. Sorry, I should write the 38 over here. Theta is 38 degree divided by m. M is 3 kg. Then I can find out that the acceleration of this block would be 3.9 meter per second square. Since it's a vector, definitely you have to give some direction. So if I choose, this is my positive x and this is my positive y, then I should write this one, the acceleration would be 3.9 meter per second square I hit. Since it's a vector, if you do not give that direction, definitely you are going to lose lots of marks. You say vector acceleration is a vector, right? Definitely I have to give that direction. Or if you do not write out in terms of ing, you can write it towards that rightward direction. Alright, so second question, I have to find out the normal force. To find out that normal force, what I will write, net force along to the y-axis is 0, right? Because the block is moving towards that positive x direction. It is not moving at all towards that positive y direction. So in the y direction, I have the three force. Two forces upward and one force is downward direction, right? So then I can write net force along the y-axis would be 0. It would be n plus 15 sine theta minus mg. That would be that force. So if I write n plus f sine theta, which is 15 sine theta, minus mg equal to the 0, I can find out from here it would be mg minus f sine theta, and in that case you can find out, if you plug in that value, m actually that 3 kg and f actually that 15 newton, then you can find out the normal force is going to be 20.17 newton, which is basically the apparent weight of this block again, because it is less than actually your actual weight, which was mg. I have to subtract f sine theta from its actual weight. It should be lower than of its actual weight. Is someone knocking me? Alright, now third question, they ask you what will be the minimum force to fly off from that surface. Fine. Remember, to fly off from that surface, definitely the normal force must be going to be the 0. To fly off from a surface, the normal force of that object must be going to be the 0. How? Say, if I explain by idea of a aeroplane, it will be easier for you to understand. Say, this is a plane, aeroplane is running into that runway. So when it is stationary, basically how many force will be acting on that plane? What are they? So one would be basically is weight, which is downward, right, mg, and another would be basically the normal force, right? That normal force will be applied on this basically the wheel of this car, because that is connected to the surface. Fine. When it start to move in the runway with the speed, say that v, in that case a upthrust will be arise onto the plane, and that arises because of Bernoulli's equation we will talk about in the case of fluid motion basically. And there is a law, it's a Bernoulli's equation that says due to that one actually a pressure will be created at the bottom of the plane. Due to that pressure it will feel a upthrust in the upward direction, right? So that's known actually the lift force. It's called the lift force. This is called F lift, which is helped to lift the plane from the surface of the ground. When you increase that V, this lift force will be gradually increased. After increasing, when it is equal to that n, equal to the n means which is going to minimize that mg, because n actually in the stationary case actually the n equal to mg, right, when it is not moving at all. Once this is say this is your n, you gradually start from 0 when your speed is 0, your lift force is 0. When you increase your speed, gradually your lift force is going to be increased. Once it's equal to that normal force, which is n, which will be minimize the gravitational attraction on the plane. After that, if you increase a little bit, then that is going to be towards the upward direction, because downward direction in that force is going to be in that case 0. They will be cancel out each other, right? Because your lift force is basically cancelling that normal force on you. Once it is greater than the normal force, then it is going to be lift off from the surface. That means it is going to take off from that runway. It means that to take off from that surface, your normal force must be that 0. That's the minimum condition. If it is greater than that, then easily it can be fly off from that surface. So for that one, we will write this equation, the whatever we writing, if y must be equal to the 0, and we write which is n plus f sine theta minus mg equal to the 0, right, in this stationary case. Then if we consider this n is going to be the 0, then this will be the f minimum. F minimum sine theta is going to be equal to the mg, right? Then I will find out this f minimum is going to be mg divided by sine theta, which is, if you plug in the mass of this case actually the 3 into 9.8 divided by sine 38, then you can find out that f minimum of this case is going to be, f minimum for this 3 kg block would be 47.75 Newton.
স্যার আপনার স্ক্রিন শেয়ার অফ হয়ে গিয়েছে আই গেস,
Is
কি
it?
আমার জন্য? Yes,
What about others?
বাকিদের জন্য কি সেম?
Yes, sir. You're not sharing your
Yes, sir. Off.
Yes, sir. We're not seeing your screen.
Oh, I'm sorry. Right now, can you see?
Yes, sir.
Yes, sir.
That's the case actually. That would be actually that f minimum. So that's mean for the minimum force, your normal force on that object is going to be the 0. When the normal force is going to be the 0, that would be that minimum condition or minimum force you have to apply. So that's mean to fly off that block from the surface for this 3 kg block at an angle 38 degree, you have to apply 47.75 Newton to lift off that block from the surface of that case. If this angle is going to be different, then you can find out what would be that case, right? So that's how actually we can find out that the lift of force for this case. All right, let's talk about that mass pulley system, which is classical pulley system. We will say this is, there are two pulley. It's a massless, remember, it's a massless and frictionless pulley we are considering over here. So then this is considered two mass, which is M1, and say this is actually the M2 connected through by a massless string. Again, I discussed about the massless string in the previous class, right? Same, for simplicity we consider M1 is greater than M2. In that case, there is a probability M1 will move to the downward at the acceleration A. At the same time, M2 will move to the upward direction A, right? I need to calculate what would be that acceleration of this system. If I want to find out that acceleration, I have to draw the free body diagram. I will draw, so this is would be M1G, this is would be my tension, and this is would be also the tension over here, T. Notice that I use the same symbol for T in the both two sides because it is connected by the same string. That's why I use that. Tension would be the same throughout that string. If the string is going to be the different, then the tension would be the different. Fine. So now over here it should be M2G, right? So this is would be the free body diagram of the system. We are not concerned about the pulley over here. This is frictionless and the massless, so that's why we neglect that part over here. Fine. Now if I consider M1 is moving to the downward direction, then I will apply Newton's second law, both masses, F equal to ma. So over here I will apply this second law for individual mass. If I consider for mass 1, since M1 is moving to the downward direction, then M1G must be greater than the T. In that case it will move to the downward, otherwise it will move to the upward direction, because the direction would be in the direction of the net force. If M1G greater than T, then the net force would be downward. If T is greater than M1G, then the net force of these two would be upward direction, right? So that's why I'll write it would be M1G minus T must be equal to M1A, right? I apply Newton's second law. F net must be equal to ma. Now for the second one, if M1 goes to the downward, then M2 will move to the upward direction. In that case I should write T minus M2G must be equal to M2A, right? You understand this thing? Then I am going to add these two equations. I will add these two equations. In that case this T will be cancelled out, the parameter over here. Then I can write it be M1 minus M2 into G is equal to M1 plus M2 into A. I just factor out the A from right side and G from left side. Then I'll find out the A is going to be M1 minus M2 divided by M1 plus M2 into G. So that should be actually that acceleration of that this mass pulley system. So that's when using the Newton's second law step by step we will be able to find out that acceleration of that system.
স্যার যদি যে কোনো একটা ম্যাচের নিচে আরেকটা ম্যাচ থাকে তাহলে
You have to draw the free body diagram in that way, and you have to apply that Newton's law step by step on every single body. You understand?
Yes sir.
Alright, say now let's consider I'm going to apply this idea for inclined plane. So that's mean I'm going to combine inclined plane with this pulley system. So I have an inclined plane which makes a angle, still is a frictionless. This makes an angle 35 degree. Say there is a pulley over here, is definitely is a massless and frictionless pulley actually we are considering. Through that pulley, say there are two mass is connected by the string. So this is that M1 and this is M2. They give us that M2 is 4 kg. I do not know the mass of M1. We have to find out that M1 over here. First condition, calculate M1 if system is stationary. System is stationary, or I can say if acceleration is 0. I can write down in a short form. If A equals 0, first question. Second question, if M1 is more than 1 kg, whatever you calculated in section 1, more than 1 kg, say if I find out when the acceleration is 0, if I find out, say that the M is 2 kg, in the third question I have to use M1 actually the 3 kg, 2 plus 1 it would be 3 kg. If M1 is 1 kg more, what would be the acceleration of the system? This is the second question. Third question, if M1 is 1 kg less, if M1 is 1 kg less, then what is the acceleration of that system? So I am considering only the magnitude. I will find out the direction also after calculating, finding this value. Fine. To solve this one, I have to again draw the free body diagram. So this is would be my M1 G. This would be my tension T. This will be also the tension T is the same string. Tension is going to be the same, right? For this one, it should be mg. This is would be N normal force. This is going to be, it's M2, I'm sorry, it's M2G. This is going to be M2G cos theta, and this is going to be M2G sin theta. This is the free body diagram, right? Fine. So if I consider the total system is stationary, so which is means that acceleration is 0, then I can say for block 1 the net force along to the x and y direction will be 0. It will move only in the vertical direction, so that's why I'm considering for y direction over here. You can consider. Then I should write T minus M1G would be 0. Then I can find out this M1 would be T by G. So that's mean if you somehow I could find out the T, then I will be able to find out that M1 divided by that G. Fine. So this is equation number 1. Now for block M2, if I consider, say this is my positive direction, say I consider this one positive direction for this one, then the net force along to the x direction for this case would be also 0, since we are considering the acceleration of the total system is 0 for the case 1, right? Then I should write T minus M2G sin theta must be equal to the 0, because T is towards the positive x direction and M2G sin theta towards the negative x direction. Then I will be able to find out T would be M2G sin theta. Now if I plug in this T into this equation, I will be able to find out that value of M1. In that case, your M1 would be, if you plug in the T, is going to be the M2G divided by sin theta. M1 would be basically M2G will be cancelled out, would be M2 sin theta. And I know that M2, right? And I know the theta, M2 actually the 4 kg and theta actually the 35 degree. Then your M1 would be 2.29 kg. So this is the answer of this question number 1. That for if M1 actually 2.29 kg, the system will be not move at all. It will be stationary. Fine. Now the case 2, they asked me if M1 is more than 1 kg right now, then what would be the acceleration? So for the case 2, my M2 remains same, which is 4 kg, and M1 is more than 1 kg, which is 2.29 plus 1, which would be 3.29 kg. Then I have to find out that acceleration. The system will be moved right now, because for the 2.29 kg it was stationary. Since M1 is 3.29 kg, definitely the system will be moved, but which direction it will move, that we have to also find out. Since I know that M2 is 4 kg and M1 is 3.29 kg, then the general idea would be that since M2 is bigger, it will move towards the downward direction, right? There is a general idea actually, and in that case M1 will be moved to the upward direction with the same acceleration a. I am to find out that acceleration. All right, so if I consider that situation over here, say after doing that calculation, if I let's say that the find out the a is negative, which means that a would be basically moves in the opposite direction of my assumption. It will be moves in the opposite direction, so with the same acceleration. But after doing that calculation, if I find out that a is positive, then my assumption would be right, it will move towards that direction. Fine. Since I consider that M2 will move to the downward, then this M2g sin theta must be greater than the t. It has to be, otherwise it cannot be moved to the downward direction. So I will apply the Newton's second law separately for these two body, for M2 body and M1 body also. If I do, then I'll write, it would be, for M2 I'll write M2g sine 35 minus t must be equal to M2a, right? This is for body 2. For body 1, since I consider M2 is moving to the downward direction, then M1 will move to the upward direction. In that case, t must be going to be greater than M1g. So that's why I'll write t minus M1g equal to M1a. I find out two equations, I'm going to add them together. So then in this case, the t will be cancelled out, which is the unknown parameter over here. Then your equation would be M2g sine 35 minus M1g would be M1 plus M2 into a. I know all the parameter over here. I know M1, M2, I know that g, then I can find out that acceleration if I plug in the values into this equation. After doing that, you will find out that this a is going to be minus 1.34 meter per second square, which means that block 2 will move to the upward direction instead of moving to the downward direction, although the mass of this block 2 is higher than block M1, right? Why? Basically this over here in the inclined plane direction, it downward force actually, that M2 g sin theta, which is basically, you can consider that mass, right? That way downward force must be basically that less than of your M1g, because M1g actually they're dragging the system basically towards the downward direction. So that's why this M2 will moves to the upward direction at a acceleration 1.34 meter per second square, and M1 will move to the downward direction with the same acceleration, which would be 1.34 meter per second square. This will be the answer, and you can write it will be moves to the M2 will move to the upward direction and M1 will move to the downward direction. You have to write it that way. So this is the answer. Now in the third case, if M1 is less than 1 kg, the third case I should write M2 is again 4 kg. So M1 would be 2.29 minus 1, which is going to be 1.29 kg. Right, it is 1.29 kg right now, more less than 1 kg. So if I assume same thing, say that M2 is moving to the downward direction and M1 is moving to the upward direction, what I will find? Let's check that. So in that case my equation would be remain same, this one. I will write down m2 g sine 35 degree minus m1 g must be equal to m1 plus m2 into a. I write down at a time. If I use the same equation for this case, I just write down the resultant equation. Then if you plug in into that value right now over here, you will find out a would be plus 1.86 meter per second square. Right now I find out that a is positive. That means when m1 is 1.29 kg, then m2 will move to the downward direction at a acceleration 1.86 meter per second, whereas when m2 actually that 3.29 kg, in that case m2 will move to the upward direction at a acceleration 1.34 meter per second square. That's how actually we can deal with this mass pulley system in an inclined plane. Alright, so do you have any question over here? Alright guys, give your attendance. Just write down your ID. Alright, that's fine. So your time is up for that. Okay, let's talk about that frictional force or force of friction. Frictional force is basically, I said, it's a electromagnetic force, right, of four fundamental force. Why? Say, when you keep a block on a surface that way, if you apply some force toward that direction, so this is your applied force, excuse me, then this surface will provide a force in the opposite direction. That is arise at the surface boundary between these two objects due to their frictional force. And how is arise this frictional force? You probably know that there will be a lot of charge, free particle will be over here, right? There will be some. So if it is one side is the excess of positive charge, then by the charge separation or the polarization on the other side of that boundary, it will be negative charge. Negative charge will be accumulated on the other side of that surface due to the charge separation or the polarization. Due to that charge separation, this is going to make a pair, it's going to be attract each other, right? They will create attractive force on that surface. So that's why a force will be arise that we call actually that frictional force, and this is also known as, it's called the cold welding. It's called the cold welding, and that's how we say that the frictional force actually that electromagnetic force of that four fundamental force. And without this frictional force, basically you cannot move. Suppose if I ask you what makes a car goes forward, probably if you say that the engine, right, because you press the accelerator, so that's why the engine is rotating. Due to that one, if you say that the car is moving towards the forward direction, Fine. What if your car is stuck in a mud or a slippery road or a ice? In that case, the car wheel is spinning, but it cannot move to the forward direction. Why? Because of basically there is not enough friction in the road. So that's mean without friction you cannot move to the forward direction, although your car in actually that rotating, your engineering is applying some force on that wheel. It means that without friction you cannot move properly. So that's why when you walk on the surface of the sand, you become tired, you cannot walk properly, you have to apply more energy, and that's why you become tired. So that's mean without friction it cannot be possible to move, right? It will be harder for us to move without the friction. So that's why this friction is basically necessary. In the case of wheel, when it is rotated basically about its own axis, you will find out some force it will be applied. I can write this is the force on the ground provided by the car, right? At the same time, this frictional force will apply some force on that forward direction, which you can write the force on car provided by the ground, which is basically the frictional force. Friction will apply that force. Due to that force, basically the car moves towards that forward direction. So that's mean without friction you cannot move in the road. It would be very hard for you. And remember, this frictional force is basically the independent of the surface area. Independent of the surface area means if you keep a block into that surface, whatever the frictional force will be acting on that block, if you change the orientation of that block in right now in the vertical direction. So right now it's covering the less amount of surface area, right, with respect to that first case. So in the both case, the frictional force on that block will be remain same. It's not going to change because this frictional force actually that independent of the surface area. It depend on actually that material property. Unless you do not change that material, then the frictional force on both two blocks is going to be the same. It's not going to change at all. Fine. There are two types of frictional force we define, which is one is called static frictional force. Static frictional force, which is active on the system when the system is stationary, and second one is kinetic frictional force that will be active on that system when the system is moving. And static frictional force will express by that Fs, F stand for frictional force and S stand for the static frictional force, and kinetic frictional force will be expressed by that Fk. Now there is a case, say that if you you have a block on the surface, it's a frictional right now. Say you apply some force on that block, you're pushing to the block towards move towards forward direction, but say that it's not moving at all. Why? That is a frictional force, right? Say initially you apply, say that initially you apply a force which is say that 2 Newton, then this frictional force will also apply 2 Newton on you. That's why that block is not moving at all, right? Say if you apply a little bit more on that force, say that the 3 Newton, probably that surface is also going to provide that back by the 3 Newton. If you apply, say that 5 Newton force onto that, right now there could be a possibility that the surface could not provide that amount of force. So that means it has some limitation of the surface. Say that limitation actually the 3 Newton, it could be provide a maximum amount of force which is the 3 Newton. In that case your block will move towards that your net force direction, it will move towards that direction with some acceleration. It means that frictional force has some limitation. We define that called Fs max. It could be maximum amount of force could be provided by the surface. and that Fs max we can find out by using that one mu s into n, where s actually the coefficient of static friction and n is the normal reaction force. That's how we will find out Fs max. So definitely if you keep some object on the surface, if the surface is frictional, if it wants to the move, you have to cross, your applied force must be greater than Fs max, otherwise it will not move at all, it will be stationary, right? Because the net force will be in the basically in the opposite direction, so that's why it will be stationary. They will cancel out that force, net force will be 0 basically in that case, so that's why it will be stationary. So and when the system will move, the kinetic frictional force will be active on that system, and kinetic frictional force we can find out it would be mu k into n, where mu k actually the coefficient of kinetic friction, and remember mu s is always greater than the mu k. Coefficient of static friction is always greater than coefficient of kinetic friction, and this coefficient of static and the kinetic friction is also independent of the mass, because it's a material property. Whatever the case, say you have a block 2 kg or the same block has a 10 kg, they have a same static coefficient of static and kinetic friction, they are the same material. If the material is not going to the different, then this coefficient of kinetic friction or coefficient of static friction is going to be the same. And remember, this is a frictionless, sorry, this is a dimensionless parameter, mu s, and the mu k basically the dimensionless parameter, it has no dimension. And that's why there is a range of this Fs, we say, which is static frictional force, that will be start from 0 or greater than 0, equal to the 0, and it will be less than or equal to that Fs max, Fs max or mu s n actually. That's how we can write down the condition of that static frictional force. And say we can find out from, say that if we draw a case, or I can draw these two force at a line, say in a diagram, say this is my applied force, I apply, this is my frictional force. Starting from the 0, when I apply the force on the system, gradually that static frictional force will be increased, and it will reach a maximum point, which is actually Fs max, right? And suddenly it will drop. So that means this is actually the maximum amount of it could be provided. After that, it will going to change its state from stationary to that moving state. Once it starts to the move, the kinetic frictional force will be active. In that case, that would be your kinetic frictional force, and kinetic frictional force will be remain same throughout its motion. It's not going to change. So that's why I can categorize, there are two reasons. One is this region where basically the system at rest, and we can say in that case the applied force is less than actually your Fs max. In that case, I can also say the system will be stationary. But in the second case, this is actually the moving state, I should say it's the moving, where my applied force is greater than actually that Fs max, and where the acceleration is not equal to the 0 actually, unless it is do not move at a constant velocity, right? And this is actually would be Fk, kinetic frictional force. That's how actually we can categorize between this static frictional force and the kinetic frictional force. Alright, say let's talk about a case. Say if you keep a block on a wall in the vertical direction, so this is your block, and say this is your wall. It's a frictional wall, remember. So generally it will not will be in that situation, right? Because it will try to move towards that downward direction, because of gravitational force will attract that block towards the downward direction. So this is my wall, which there will be some frictional force. So if I want to keep that block into that point, then I have to apply some force, right? I will apply some force towards that direction, which is this. Say that this is the applied force, not the normal force. Normal force would be in the opposite direction. So this is would be my applied force, say that F, and this is would be my normal force over here. Then how this block is going to be stationary in that case? Still there are some force in the downward direction. Do you understand what I am saying? If you keep a block into wall by your hand, that is not going to fall to the downward direction. That is my question, why it is not. Although I am applying the force in the vertical direction of your mg, which is the downward direction, right? I am applying this force, but to move the force towards the downward direction, downward force is mg. How this F is going to be minimized, that downward force over here? This is a real case, right? If you hold on a book on your wall by your hand, that if you do not apply a force, the book must be moved to the downward. But when you hold on, that means when you apply some force on the book is not going to move to the downward. My question is why? How this your applied force going to be the minimize the downward force, which is in the two different directions. The angle have a 90 degree, right? That one, when you can explain in that way, when you basically increase this your applied force, in that case this normal force will be also going to be increased. Whatever the force you are going to apply on that book, the wall will also provide the same amount of force on you, right? Then when that n is arise, then I can say there will be a frictional force to hold that book, that would be in the upward direction, which is say that Fs. And that Fs, I know that relation Fs actually that mu s into n. This n actually the play that role to hold that book into that position, because that n is also directly connected to my that applied force. And that's why when you keep a book onto wall, actually that your applied force, your normal force is going to be the increase, that or normal force actually they play the role to hold the book on that wall. You understand? All right, let's talk about another case. That's called actually that limiting angle. Limiting angle or angle of reproach. It's a very important concept also. Say, think about you have a inclined plane. That inclined plane can be rotated about this point. If I kept a block over here, it's a frictional. Right now we are dealing with frictional case, general case. Say, I apply some force onto that side of this inclined plane. As a result, it will be rotated towards that direction. Say, after a certain point, the position of this system is over here. I increase that theta gradually. Gradually, I increase. There is a reason why I am using, because I know at a certain point this block will move towards the direction, downward direction, right? It will. When that downward force is going to be greater than your upward force, then definitely that block will move to the downward direction. I want to find out that angle, at what angle it will move, just try to move to the downward direction. That's called actually the limiting angle, or sometimes it is known as also angle of reproach. I have to find out that angle. Fine. If I draw the free body diagram of that system, I can say this is would be my mg, this is would be my normal force, this is would be my mg cos theta, and this is would be my mg sin theta, right? And this is would be your frictional force, Fs. I write down the Fs or Fs max, whatever you say. So because it would be Fs max, because I have to find out that point, at point when it will just equal to, if mg is greater than Fs max, then the block will move towards the downward direction. right? If its mg sine theta is less than fs max, it's never going to be moved to the downward direction. It will be stationary into that position. So that means I'm considering a case when these two forces are equal, just to the equal. Mg sine theta must be equal to fs max. That means it will be on the verge of this motion. Right? It will just try to start to move. I'm considering that is called the limiting case, actually limiting angle. All right. This equation is I can find out. Say I'll consider this is my reference x-axis and this is my reference y-axis. In that case, I'll write down the net force along to the y-axis would be 0. In that case, n minus mg cos theta would be 0. I'll find out, say that n would be mg cosine theta. So this is equation number 1. For the second case, I'll find out this equation over here. Say I'll write that f of x would be also the 0. It is still it is stationary basically. I'll write in that case fx max minus, or whatever I'll directly write down, mg sine theta, actually that equation number 2. I'm going to divide these two equations 2 by 1. What it will give me? It will give me I'll find out mg will be cancelled out from the right hand side. It will be fs max divided by n would be tan theta, right? And fx max I can replace by, I know that fs max actually that mu s n, right? That's the definition. Then fx max divided by n is basically the mu s. Then I can write down theta would be basically that tan inverse mu s, which is that coefficient of static friction. So that's mean if you just know that coefficient of static friction between that two surface, then you can find out what would be that angle of repose. That's mean at which angle your block is going to be the most to the downward direction. If you just know the coefficient of static friction, using that formula you can find out at which angle it will be just try to move to the downward direction. Alright, so let's think about another case actually. Say this is the inclined plane. Try to understand, this is very important concept or important thing actually for that friction. So I take this problem from your reference book. This is a very good problem from the friction. Say I have a block onto that inclined plane and they give that weight of this block, which is mg, I should write the mg actually that 45 Newton, and the angle is 15 degree. Angle is 15 degree, and they give us the coefficient of static friction is 0.5 and coefficient of kinetic friction is 0.34. The system is basically the stationary, it is not moving. You can find out that case. And if I draw the free body diagram, so this is would be my mg, this is would be my normal force, this is would be my mg cosine theta, this is would be my mg sine theta, and this is would be basically that frictional force. If I do not know whether it is stationary or the moving, I have to check that one. So that's mean if I consider this is stationary, it would be fs max actually over here acting, because your downward force in that case is not greater than fx max. I have to check that one. Now what they did actually to move that system, they apply a force in that direction, say that P, and that P is gradually they increase. Say that P initially they apply the 5 Newton, second time they apply the 8 Newton, and the third time they apply the 15 Newton. And every time they ask me calculate the frictional force. What is that frictional force on that block? The question is this one. Do you understand my point? Fine. So first I have to check that whether the system is stationary or not at all. So if it is stationary, then it would be basically the static frictional force. If it is moved, then it would be kinetic frictional force, right? I have to check that one. So let's first check that what is my Fs max first. Fs max would be mu s into n, right? N would be from there. I can find out if you consider, so this is your positive x direction, this is actually your positive y direction. The block is not moving at all in the vertical direction. I should write Fy would be 0. In that case, I can write N would be mg cosine theta, right? Then Fs max, I can find out this Fs max is going to be mu s into mg cosine theta. I know that every value over here. I know that mu s, which is 0.5, mg 45, and theta actually the 15 degree. If you plug in, you will find out that Fs max is going to be 21.73 Newton. So this is actually that Fs max. It means that if the block wants to move toward the downward direction, definitely the force must be, net force toward the downward must be greater than 21.73 Newton. Let's check that when is actually there is no P into that case. The what is the mg? Mg sine 15 degree, which is, what is that? Let me check. So this is actually the 45 into sine 15 degree. So sine 15 is 0.25 into 45, which is 11 point something. So 11.64 Newton, which is less than actually that your 21.73. So that's why the system is not moving towards the downward direction. To move that, they apply that force P over here. Initially they apply the 5 Newton. So in that case, my downward force would be Fd would be mg sine 15 degree plus P, right? So these are the two force, downward direction, mg sine 15 and the P. And I find out that one. So let's check that mg sine 45 actually 11.64 plus P is 5, right? Which gives me actually that 16 point something. It would be 16 point how much is this? It's 16 point something, right? 16.64 Newton, which is still less than your Fs max. Am I right? It means that when I'm applying the 5 Newton, still the block will not move to the downward direction. That's fine. Then what would be my frictional force? It would be static frictional force, right? This Fs, what would be that force right now? Can anyone tell me what would be that frictional force if the system is not going to move? What would be that frictional force if the system is not going to move? Because my downward force is 16.64, but the upward force,
16.7,
it would be how much?
like just greater. 16.7, because
16
this is 16.64.
It would be
or
16.64,
17.
right? Because by the, since you are applying the downward force actually that 16.64, by the Newton third law, the friction will also provide you the same amount of force but in the opposite direction. So that's why it is not moving. It has that 21.73, up to that it can be provide force in the opposite direction. It has that capability for by the surface, right? Since I find out that downward force is 16.64, which is less than my Fs max, it means that the block will not move to the upward direction. Right now, for this case, when I am applying 5 Newton, the frictional force on the block would be 16.64 Newton. That's the answer of the first case. Do you understand this thing? This is a very important concept to understand how the frictional force is acting on the system. Second case, when P actually that 8 Newton. Let's check that what would be my Fd in that case. It would be 11.64 plus 8. What would be that value? It would be 19.64 again, right? 19.64 2.64 Newton, which is still less than your Fs max. That means the block is still not going to the move. Then I can say my frictional force on that block would be Fs, which would be 19.64, and it would be also the upward direction. You have to dig upward. You have to also mention the direction because it's a vector. It should be the upward in the inclined plane. That's the answer of this one. Remember, if you do not express the vector in that way, you will definitely lose some marks in the exam. I'll reduce your marks if you do not express the vector in that way. Either you have to mention in term of unit vector, or you have to give some magnitude and the direction. Fine. What about in the third case when P actually that 15 Newton? In that case, my downward force Fd actually 11.64 plus 15, which is going to be 26 point something, right? It's going to be 26.64, which right now greater than your Fs max, because Fs max was 21.73. This was my Fs max. Right now your downward force actually crossed that maximum limit, and then the block is, for the third case, it will move to the downward direction. Then what will be that frictional force right now? Right now, since it's moving, definitely the kinetic frictional force will be active on the system. I should write mu k into n. I know that mu k, which is point, how much that mu k, actually that 34, and I know that mg n, which is mg cosine theta, right? So you can find out, in that case you will find out it would be 0.34 into mg cos theta, which is 45 cos 15 degree. You will find out that Fk would be 14.77 Newton. That is the frictional force on that system. And now if I ask you at what acceleration the block will move, then you can write down this equation. For the third case, it would be P plus mg sine theta minus Fk would be ma. I know that P plus sine theta, I know that Fk separately, I know that mg I can find out by divided by the g. Then if you plug in those value into this equation, you will find out that the acceleration of that block would be right now 2.58 meter per second square downward. Right now it should be in the downward direction. So that's how actually you can handle with this frictional system. That would be the answer of this case. Alright, I am done for today. This is also there are some problem also from there are few more problem I'm going to solve. If I get the time, I'll try to do that in the next class. I'll try to do one or two problem in the next class from the general case of the friction from this chapter, and rest of the problem I will solve and I will upload it in the YouTube. Please try to access this thing from there, because otherwise I cannot complete my syllabus. The next week I am also going to be talk about that circular motion. I have to finish before the meet. Alright, thank you very much guys. I'm done with you. If you don't have any question, you can leave.